What is time? What most people think of time as a constant, physicist Albert Einstein showed us that time is just an illusion. It is relative. It can vary for different observers depending on the speed through space.
According to Einstein, time is the fourth dimension. Space is a three-dimensional arena which provides a traveler with coordinates such as height, length, and width. Time travel to the past is theoretically possible in certain general relativity space-time geometries that permit traveling faster than the speed of light, such as cosmic strings, transversable wormholes, and Alcubierre drives.
Time travel. The concept of time travel is basically based on the movement between certain points of time, past, present, and the future. Time travel is theoretically possible, but it hasn't been proven yet. Now, for example, let us take a light particle, the fastest particle in existence. When a body moves faster than the fastest particle in existence, the world around you will stop. And if the particle keeps moving faster and faster, the world around you will keep getting slower and slower, thus moving back in time or slowing down time.
Einstein's theory of special relativity says that time slows down or speeds up depending on how fast you move relative to something. Approaching the speed of light, a person inside the spaceship would age much slower than his twin at home. Also, under Einstein's theory of general relativity, gravity can also bend time. Picture a four-dimensional fabric called space-time. When anything that has mass sits on the piece of fabric, it causes a dimple of bending, which is called bending of time-space. The bending of time-space causes the objects to move on a curved path, and that curvature of space is what we know as gravity. Both the general and special relativity theories have been proven with GPS satellite that has very accurate timepieces on board. The effects of gravity as well as satellites increase speed above the Earth's relative to the observers on the ground.
Hi, I'm Narendharan. I'm going to talk about black holes. Well, the idea of black hole, an object so massive that nothing could escape the grasp of its gravity. But the modern history of black hole starts from Einstein's theory of gravity. Black holes and wormholes are similar but very different. A wormhole creates a bridge between 2 points, but a black hole leads to a dead end. However, black holes are even stranger than that. As you get closer to a black hole, the flow of time slows down. At the very center of the black hole, where our understanding breaks down. Einstein's theory of gravity seems to predict that time itself is destroyed at the center of the hole, meaning time itself comes to an end. There is still no proof on this, but our understanding of black holes is very limited. Thank you.
A wormhole is a speculative structure linking disparate points in spacetime and is based on a special solution of Einstein's field equation. A wormhole can be visualized as a tunnel with two ends at separate points in spacetime, like different locations, different points in time or both. Wormholes consist of the general theory of relativity by Einstein, but whether do wormholes actually exist? Many scientists postulate that wormholes are merely projections of the fourth spatial dimension, analogous to how a two-dimensional object can experience only a part of the third dimensional object. A wormhole could connect long distances such as billions of years or more, short distances such as few meters, different universes or different parts in time.
What is a triplet cylinder? A triplet cylinder, also called as a triplet time machine, is a hypothetical object theorized to be a potential mode of time travel. Although results have shown that a triplet cylinder could only allow time travel if the length were infinite or with the existence of negative energy. The Tipler cylinder was discovered as a solution to the equations of general relativity by William Jacob Wang in 1936 and by Cornel Lanczos in 1924. But it was still not recognized as a closed time-like curves until an analysis was done by Frank Tipler in 1974, in which he had stated that a Tipler cylinder recognizes a closed time-like curves, and hence it was named after him.